we're looking at this question where we're given a joint PMF of X and Y. In the first part, we found the joint commutative probability. And then now in the second part, we want to find the conditional PMF of X given Y is equal to 0. So let's do this. Let's do part B. So part B is, part B is for conditional PMF of Y given X is equal to 0. That's what we want to find, the conditional PMF of Y given X is equal to 0. So we essentially want to find the probability Y is equal to Y given X is equal to 0 for all possible values of Y. And we know these are the possible values Y can take, 3, 4, 5. So let's first find probability Y is equal to 3 given X is equal to 0, right? Because we need to find the probability Y is Y given X is equal to 0. And you want to do it for every possible value of Y. So we start off with probability Y is 3. So now let's apply the definition of conditional probability. This is probability Y is 3 and X is 0 divided by probability X is 0. So what we're doing here, we're just applying definition of conditional probability, which is the probability of A given B. Sorry, let me write it in the next line. Given B is probability of A and B divided by probability of B. And this basically comma means and or intersection, right? This is what it means, right? So this is applying the definition of conditional probability, probability A given B. So it's probability of A and B divided by probability of B. Now let's see what this is. So let's now identify what this is. Probability, probability Y is 3 and X is 0. Now this is a joint probability which we can directly read from the PMF. So this is the probability Y is 3 and X is 0. So it's 0.09. You can directly read it from the joint PMF because that's what the joint PMF gives us. It gives us the probability. So that's what the joint PMF is meant to give us. The probability X is X and Y is Y. Right? So this is basically 0.09 divided by, we want to find the probability X is 0. Just before that, let's just write it over here. So joint probability of X and Y. So this is the joint probability of X and Y, which we can directly read from joint PMF, which we can directly read from joint PMF, right? So it is essentially this value, right? The joint probability where Y is 3 and X is 0. Now let's look at the next thing. We want to find the probability X is 0. How will we find the probability X is 0? Well, to find probability X is 0, remember we said we can use a joint PMF to find any probability concerning X and Y by summing up the joint PMF over those values of X and Y. So to find probability X is equal to 0, sum up the joint PMF over all those values where X is 0 regardless of what Y is. Because we know we can use the joint PMF to find any probability of X and Y by summing of the joint PMF for those values of X and Y. So if I'm interested in the probability X is 0, so I just sum up the joint PMF over all those values where X is 0. So this is where X is 0, right? So it's all of these values, right? These values in the joint PMF are where X is 0 regardless of what Y is. So what you have to do is you just have to sum up the joint PMF for all those values X is 0, which is this column corresponding to X is equal to 0, right? So basically, how will we find, so this gives us probability X is equal to 0. So now, if we go back, so what is probability X is equal to 0? It's just 0.09 plus 0.07 plus 0.03. So if I simplify this, we'll just add these up, divided by 0.19. So this is the probability X is equal to 0, right? And then this probability turns out to be 0.47. So this is how we found the probability y is 3 given x is equal to 0. But we wanted the conditional PMF of y given x is equal to 0. So we need to find this probability y is equal to y given x is equal to 0 for all values of y. We're done for y is equal to 3. Now we need to do the same thing for y is 4 and y is 5. So let's do that. We'll do it now for the other values of y. Right, you need to do it for all values of y. So we've done it for 3. Now let's do it for 4. So basically we want to find the probability now y is equal to 4 given x is equal to 0. Now again apply the definition of conditional probability. This is probability y is 4 and x is equal to 0 divided by probability x is equal to 0. This is, let's just erase this up. This is again a joint probability of x and y, which you can directly read from the joint pair x and y. So this is y is 4 and this is x is 0. So this is the probability y is 4 and x is 0, because keep in mind the joint PMF gives us the probabilities y is y and x is x, right? So this will just turn out to be probability y is 4 and x is 0 is 0.07, and probability x is equal to 0 we just found in the previous part when we were finding probability y is given x is 0 as 0.19. So it turns out to be 0.37, right? So now we're done with probability. We're done with finding probability y is y given x is equal to 0 for y is 3 and y is 4. Now we're just left with y is equal to 5, right? Now let's do it for y is equal to 5. So now we want to do the same thing for y is equal to 5. Now probability y is 5 given x is equal to 0. Again apply the definition of conditional probability. This is probability y is 5 and x is 0 divided by the probability x is 0. Again, like we said, this probability y is 5 and x is 0 is the joint probability of x and y, which you can directly read from the joint PMF, right? So this is where y is 5 and this is where x is 0. So this is 0.03 is what we are looking for. Right? So this is 0.03. Probability x is equal to 0 we already found is 0.19. So this just turns out to be 0.16. In this way, we found the joint PMF, or conditional PMF of y given x equal to 0. If I was interested in just the marginal, the individual PMF of y, so then you would have just found the probability y is 3, 4, and 5. Why 3, 4, 5? Because these are the values y takes. But we were interested in the conditional PMF, so we essentially found probability y is 3 given x is equal to 0, which turned out to be 0.47. We found the probability y is 4 given x is equal to 0, which turned out to be 0.37. And we found the probability y is 5 given x is equal to 0, which turned out to be 0.16, right? So we run it for all three values of y, right? So if you're finding the conditional PMF of y given x is equal to 0, you find the probability that y takes all of these values given x is equal to 0. And how did we know we needed to do it for 3, 4, 5? Because these are the values that y takes, which you can see from the joint PMF. So now let's do part C. Part C asks us to find the conditional PMF of x given y is equal to 4. So now we want to find the conditional PMF of x. So let's just erase all of this. So we want to find for conditional, so this is part C, for conditional PMF of x given y is equal to 4. So we essentially want to find the probability x is equal to x given y is equal to 4. And because you want to find the conditional PMF, we want to do it for every possible value of x, which means for 0, 1, and 2. So let's start with 0. Sorry, let me just wait. So probability x is equal to 0 given y, not y, sorry, this should be y is equal to 4. We want to do this given y is equal to 4. Given y is equal to 4. Apply the definition of conditional probability. So this is probability x is equal to 0 and y is 4. Divided by probability y is 4. So now this we know again is the joint PMF of x and y, which you can directly, sorry, this is a joint probability of x and y, which you can directly read from the joint PMF. This is where x is 0 and y is 4. So it's this value 0.07, right? So this is 0.07. We want to find the probability y is equal to 4. Again, how will we find this? Let's just quickly, so we'll to find probability y is 4, sum of the joint PMF over all those values where y is 4, regardless of what x is. Because remember we said if you want to find any probability using if you want to find any probability using the joint PMF, you just regarding x, y, just sum of the joint PMF of those values of x and y. So I'm interested in the probability y is 4. I'm just going to sum of the joint PMF over all those values with y is 4. So this is y is equal to 4, and these are all those values with y is 4. So I'm going to sum up the joint PMF over all these values, right? So essentially summing up the joint PMF, we're just adding up all the values in the row corresponding to y is equal to 4 in this case, right? So then this would just be 0.07 plus 0.23 plus 0.16, and sorry, my bad. And this would just turn out to be 0.07 divided by 0.46, which would turn out to be 0.15. So we've done it for probability. We have found the probability x is 0 given y, so now we need to do it for probability x is equal to 1 and x is equal to 2. Right, so if we want to now do it for probability x is equal to 1. So now we want to find the probability x is 1 given y is equal to 4. So how will we find this? So this will basically again apply the definition of conditional probability. This is probability x is 1 and y is 4 divided by probability y is 4. Again, this is just this is the joint probability of x and y. You can directly read from the joint p x and y. So this is x is 1, this is y is 4. So this is the probability x is 1 and y is equal to 4. Right, so what this is going to be, this is just 0.23 divided by probability y is 4, which we just found as 0.46. So this is 0.5. So now we're just left with, so we're done with probability x is 0 given y is 4, probability x is 1 given y is equal to 4. Now we need to do it for x is equal to 2, and then we'll be done with the conditional PMF of x given y is equal to 4, right? So now I want to find the probability x is 2 given y is equal to 4. Again, apply the definition of conditional probability. This is probability x is 2 and y is 4 divided by the probability y is equal to 4. And as mentioned, this is the joint probability of x and y, which you can directly read from the joint PMF of x and y. So this is the probability x is equal to 2 and y is equal to 4. So it's 0.16, right? So this is just 0.16, and you already found the probability y is equal to 4 as 0.46. And this also turns out to be 0.35. So in this way, we found the conditional PMF of x given y is equal to 4. So for this, what we did was, let's just conclude this up. So we found the probability x is equal to 0 given y is equal to 4, and we found this to be 0.15. Right, so we did it for this value of x. Then we found probability x is 1 given y is equal to 4, which was 0.5. So we found it for this value as well. Then we found probability x is 2 given y is equal to 4, which was 0.35. So we found it for this value. So we're done with the conditional PMF of x given y is equal to 4.